Hi guys, and welcome back in my channel. In this video I want to show you a way to transform any kind of image or 3D mesh in a simple and cute 2D pattern in geometry nodes. This can be useful for promotion, marketing, logos, websites and whatever. So let's get started. I'm working with Blender version 4.5.3. I'm taking time to pass in the new version 5.0. So I think the next video tutorial will be done in the new version. So to start this tutorial, we need a simple plane. So you can press Shift A, Mesh, Plane, go in the workspace, Geometry Nodes here, or in the plus menu, General, and Geometry Nodes. Press New to create a new setup. First of all, we need to have an image reference in our setup, so we can introduce with F3 the image node like this. But because we don't have any input to expose in the group input, we are not going to use this node, but the friend image texture node. In this way, we can expose the image directly in the group input. Next, we need to have a grid, okay, to replace this plane, and we can connect this to the group output. Next, we need the information of the size of this image to control the sizes of the grid. And to do this, we need to use an image info node, and we can directly link the image inside to get the width and height. We can link directly the width and height here, but here we have the number of the pixels of the image. So keep in mind, if you are working with meters, these will be interpreted as meters. So instead of using this number for the number of the meter, we need to multiply these values by a factor to divide these by 1000. So multiplying it by 0.001. The same for the height, and this is the final grid. We can go in the modifier and we can open our image. Okay, I chose this image made by the AI. So to see the image, we can go in the texture paint workspace and select from this menu the cat, and this is our reference image. So what we need is to create a 2D pattern based by the luminance of this image, cutting away the white part. So turning back in the geometry nodes, we can see the same result on this grid, pressing Ctrl-Shift-Click and Ctrl-Shift on the image. But you can see this particular behavior. Why? Because we have not enough pixels or points in the grid. As you can see, if I press Shift-Z, so to make it better, we need to use a subdivide mesh. We can increase 6 times, for example. And another problem is the position of our image inside the grid, because we have a different UV or position information to get these image colors from this image texture node. So we need to use this grid UV map inside this image. And as you can see, we have the perfect image aligned in the center of the grid. Now, if I press Shift-Z, you can see the proportion of the pixels is not right. So we don't have a correct ratio between the width and the height. So we need to fix this problem, increasing or decreasing the starting vertices of the grid. So to do this, we can easily define the correct number of vertices of the X based by the ratio between the width and height. So if I take this number and divide this by the result of the height, what we have is the ratio, so the proportion between the width and the height. So if we have a square, we have the division equal to 1, because this length is equal to this length. But if we have a rectangle like this, we have a width bigger than the height. So we would have from this division a value greater than 1. Okay, so 1.6 or 2, for example, if we have a rectangle based by 2 squares. So if this is L, we have here L multiplied by 2. Okay, so this is the factor okay, the proportional factor between these two values. So in this way, we can divide in the correct starting point the grid before the subdivide mesh. We can start with a value of 2 vertices because it's the minimum value we can set here, and we can set the y, and for the x we can multiply this initial value by this division. In this way, if I zoom in and set the correct socket in the correct socket, you can see a perfect square. Always, okay, even if I have a different width and height of the image. Now, why did I decide to have the same proportional size for the pixels? Because we are going to use a merge by distance, and I want to have a proportional effect of this feature. So what we can do is to link this subdivision in the output. We can duplicate this group input to link the image here. I enable the snap tool, Ctrl H to collapse this node. We can select all these nodes, press F to make a frame, prepare the plane. Next, we can move these pixels a little bit based by a noise effect. So to do this, I'm going to use a reroute here for the image. We are going to use next, and here a Voronoi texture. You can choose a different pattern if you like it. We can expose in the group input the scale and the roughness of this Voronoi texture to have a better control in the modifier. Next, we can use a set position node like this, and we can use the position of this node. So this position means that each of these zone has the same common position information of this Voronoi texture. And if you look from a big point of view this image, you can see we have a little offset from an original position based by the original UV map. Okay, so the UV map starts from here, from 0 to 1, in this direction on the X and on the Y, and decreases in the opposite direction to have negative values. And inside these cells, you can see a common value for each zone. So the idea is to link this position to the new position of our vertices of the mesh. But we don't need to use the Z information, because if I link these to the view, you can see a great result from this perspective. But if I move the point of view in this way, we have a wrong result. So we need to separate this information and use the combine to link only the X and the Y, or you can use also the multiplication with 1, 1 and 0. So in this way we can isolate only the X and the Y, leaving 0 for the Z information. And this is now correct. We can turn back here. We can increase the scale like this. We can open the group input information, and in the scale we can set 0 for the minimum and a structure single. The same for the randomness. Subdivision factor from 0 to 1 is correct. We can increase a little bit this value. Now what we need is to delete the geometry that doesn't respect the luminance of our image. So the luminance is the value from 0 and 1, so from the black value and the white value. But because we have an image with colors like this, we need to change this color in a grayscale ramp. And to do this, I can show you this little trick to transform any image in a grayscale result, easily multiplying the color by a value, not a vector value, because we need to have an average of these three values, the R, G and B colors. So we need to use a math with only a float value, multiplying this color by 1. So this result is equal to merge and make an average between a vector information and a float information. So Blender does this operation for us. So this means that if you have an RGNB value of 1, the average is 1. So you have a white, perfect white output. If you have 0, 0 and 0, you have 0, so black. Any other values between 0 and 1 for each component of the color will give you a value between 0 and 1. So if you take this value and use this for the R, G, and B, you have the same factor for both of these three components, and you get a gray value, lighter or darker. So in this case, we need to get this final information from 0 and 1 to have a threshold in the group input and compare this threshold with the luminance of this image. I can show you this result, so if I press Ctrl Shift and click, you can see the equivalent gray scale of this image. This is a linear algorithm, but I know that there are some other algorithms to calculate the correct and precise luminance to follow a more correct perception from the human eye. Now we can ask if this is less than or equal a threshold we can add in the group input, and we can call it threshold, and this is a factor between 0 and 1, type single, and the result of this, if I increase a little bit this tolerance, is this, okay? This is the part we want to maintain. So if I add here a delete geometry node, and if I link this result here and link this to the viewer, you can see we deleted all the wrong part of the image. So we need to take this Boolean output and pass through a not Boolean operation to get the opposite Boolean results and have the correct deleting behavior. We can press G to collapse a little bit. Instead of threshold, we can rename it in max brightness. We can adjust this result of the deleting geometry using a merge by distance node here in the middle and exposing these in the group input like this. We can rename it in merge distance. To have a better result, we need to delete not the point but the face. So in this way we can have a better mean value for the compare operation on the mesh, and as you can see we have this little part of the mesh away, so we need to delete this part using another delete geometry node here, setting here edge, and we can ask if the edge neighbors, so the number of the face count, is equal to 0. So if this is correct, we can delete all these edge. We can press Ctrl Shift and click to see the result, and now we have a better and clean mesh. We can move these nodes a little bit. Okay, this is the second part, so we can select all these nodes, press F, get and clean the primitive shape. I can increase a little bit this merge distance, like this, for example, and now we can set the rear level. So we are going to have two levels, one in front of the mesh and one behind. So we can start with the rear part that will have a higher number of the merge distance, so we can use this starting value. And for this reason, I'm going to take the max brightness and move this up a little bit, create a new panel called rear, moving this merge distance inside. Now if I cut this viewer, you can see only the edges of this mesh, so we need to create a real mesh, and to do this we need to convert this mesh in curves, and for this I'm going to use the mesh to curves node using the edges. Next we need to reconvert this to a mesh using a curve line like this to have a start and an end point. So if I press Ctrl Shift, you can see this is the line. Okay, on the Z we don't want this result, we want to have the result in the X axis for both of these, because the system will use the X axis to have the width of the profile and the Z axis to follow the path. For this reason, we can use a combine XYZ, duplicate these to have the correct end result here, and to have an aligned and centered aligned profile curve, we need to have a negative value for the X and a positive value on the X for the start and the end point. We can add here an input. This is the thickness. I can add a group input node, link these in the positive x-axis of the end, and link these in a multiply math operation, multiplying these by -1 and link this value to the x of the starting point of the curve line. In this way, if I go here and set, for example, 1, you can see we have the positive 1 here and the negative 1 in the other side. We can link these in the profile curve to see the result here, and this is the bad result. Why? Because we have too big thickness. We can set the subtype in distance from 0, set structure to single, and set, for example, 2 millimeters. And this is the result. Shift Z to see the mesh. Now we can instance circles on the points of this mesh, and we can use the circle curve, exposing the radius in the group input. In this way, we can link these in the rear, like this, below the thickness. This radius is a distance from 0, and this is a single value. We can link these in the instance and decrease these a little bit, for example, 5 millimeters, maybe. But we have a problem. You can see we have overlapped circles because transforming the mesh in curves and then again in mesh using this curve line, we have what? We have all these points here. Okay, so what we need is not instance the curve circle at the end of this curve to mesh, but use the mesh to curve here. Okay, in this way, we have only one point derived by the control point of the curves. Okay, so this point here from these curves. Okay, and another problem is this. So after the instance operation, we don't have any surface, any mesh inside because we have only circles. So to fix this problem, we can use a mesh circle instead and link this radius here and this in the instance. In this way, we can choose from here the n-gon to fill the entire circles inside this mesh. Now we can join these together. In this way, we can have these lines and the circles. We can decrease a little bit the thickness to 1 millimeter to better see the circles. And what we can do is to make a random scale for these circles, linking these in a random value. And instead of using the vector, I'm going to use the float value because we need to use the same value for all the three components, x, y, and z. So we don't need to work with vectors. And what we need is to have a factor from 0 to 1 to make the randomness. And here we can add a new socket called random radius. This is a factor from 0 to 1, structure type single. Now I can duplicate this group input, and because for me the maximum value needs to be the exact scale of the radius passed inside this mesh circle, and I remember you, the system will multiply the radius of the instance by the scale inside this instance on points. We need to maintain the maximum value of 1. So this radius multiplied by this scale, this maximum scale 1, to have the same value of the original radius. And for the minimum value, if I leave 1, we always have the same scale for all these circles. And what we need is to manipulate this min value to go from 0 to 1 to increase the randomness, but I can't link this directly because if I want to have more random, I want to increase this value. But if I increase this value, I'm going to set a value of the mean near the same value of the max, so 1. and I want the opposite thought. So what we need is to link these in a map range node, like this, and invert this from min and max range to a minimum of 1 and a maximum of 0. In this way, if I have 0 as the minimum, I want to have the final minimum equal to 1. So the same value of the max, so the same scale and the same radius for all these circles. If I increase this to 1, I want the maximum randomness, so I want to decrease the output from 1 to 0, so decrease the minimum of this random value to have the maximum randomness effect for the scaling. And you can see this effect here, for example. Now what we can do is to transform this geometry to a single instance to work with only one object and store an attribute, and this is a color, so the color of the rear part for each instance, because now this entire mesh is converted in a single instance, and we can set here v underscore col for color, and I usually use the prefix v underscore to have a different naming convention between me and Blender, so the original variables, because sometimes if you use the same name of the already existing attributes of the mesh or other stuff, you can have weird results for the shading or other part of the modifier stack. And V is for variable. It's simple. We can expose this in the group input like the other attributes. We can move this value inside the rear zone like this and rename this in color is a single value. And because this part is the rear part, we need to move this a little bit down on the z-axis to not have the overlapping issue with the front layer. So we can take this and use the transform geometry, because we need to translate all the part in a minimum 0.001 value. You can decide whatever value you want, but in the negative direction. It's obvious I'm using here a single color, and next I'm going to use an emission shader to also not have free shadow. I don't want to have on my final 2D pattern. I can select all these nodes, press F, and call it rear. I can move it up because I need to duplicate these to make the front part that is similar to this. I can take these, press Ctrl Shift D and duplicate it. We can rename this in front, and before going in the mesh to curve node in this direction, we need to have a more merge by distance operation on the mesh, because the effect is that the front layer has more bigger spaces between the curves and the circles rather than the rear part. And not only this, but I want to merge only the inner zone, so the inner vertices of the mesh, leaving as is the boundary part for the selection of the merging operation. So here I want to use a merge by distance another time, and I need to expose the distance in the group input, and now we need to make another panel for the front zone like this. Front we can easily take and move up a little bit. We can move this distance here inside, and this is the merge distance for the front part. We can duplicate the thickness and move in the front, duplicate the radius, the random radius, and the color. Now, as I said, I want to merge the vertices of this mesh using only the connected part, so I don't want to merge, for example, this point with this point, okay, but only this point with the already connected vertices, and select only the inner vertices for the operation. So I'm going to use the edge neighbors. From here I want to ask me if this is greater than 1, and link this result here. In this way, if I press Ctrl Shift click and go in the point domain for the merge distance, you can see this part will remain like this point here and this point here, and I'm going to use all the inner part and some on the boundary. Now I can increase this front but you can see we don't see anything because we are looking at the output from the rear part. So we need to join or link for a moment this output here. I need to delete this transform geometry, and I can press, for example, Shift, Control, and click here to see the result of this merging effect. So I can increase a little bit like this. We can move these nodes a little bit down, this here, and this here. In addition, we need to use a different thickness and all the other attributes because we have the new in the front zone. So I need to take these, and instead of linking this thickness, I need to link this thickness. The same for the radius. So instead of using this random radius, we need to use this random radius, like this. The same for the radius, and the same for the color. So I need to take this new socket. We can set correct values for the radius, random radius to 0, and now we can join them together. So we can press Ctrl Shift, right click here to make the join geometry. We can delete this viewer, and you can see the different pattern, the front and the rear. Now we can set the material here, and we need to go in the material section, create a new material, graph, and inside the shading, we can add an attribute like this, go in the instance here domain, not the geometry, because we have two instances, and get the color information. Drop the principal BSDF and add an emission. Link the color here and the emission here. Now you don't see any difference because we don't have any color set here. If I change these other colors, you don't see anything because inside the geometry nodes we need to select our graph colors. Now if I go here, you can see the preview and we can change the values. We can also add a background based by the original plane. I'm going to use the same color used for the video intro. I set some values here in the modifier, but you can see this particular issue. If you prefer, you can use this result if you want, but I prefer to maintain the rear part behind. As you can see, we have a little glitching based by this little number for the transform geometry. So if you have this issue, increase this value in the negative direction. So for example, set this to -0.1 to not have any glitching. Look in this point of view, so the viewport or in the rendering stage. To have a background, we need a new panel here, so we can collapse these two panels, make a new one, rename it in background, and we can also go here and set the panel toggle to have an automatic checking feature for the background panel to enable or disable this feature. Now we need a switch node and link the original if false, add the group input node and link this background in the switch if we want to have the background part, link this in the geometry output, and now we need to link the result in the true condition. And we need to start with the plane, okay, the starting plane. And for this reason, I can drag this output to a reroute, drag this line in a new reroute like this. And now, because we are working with instances, we need to transform this plane in an instance too. So we can drag this in a geometry to instance like this. We can store the color of this background like vCol for instance, and this is a color information. Link this to a group input another time, but this time we need to move this in the background, calling this color, and this is the background, so I can set a pure white value. This is a single structure color, and now we can use the transform geometry because we need to set the background. So if I enable this and I link this in the true, we need to join this output in the join geometry here and link this geometry in the set material, dropping this value because we want to have all the meshes and also the background if we want, or nothing for the background, so leaving this false with no mesh output and link this scale in a group input, transforming this from a vector to float to use the same value for the 3 components, and moving this in the background. Why this? Because maybe you want to increase proportionally the size of this original panel, because the vertices that we made could overlap the boundary of the background itself. So to fix this problem, we needed to set a minimum of 0 in the scale, a default value to 1, and if I set 1, you can see this issue, okay? You can see these overlapping or worse, like in this case. And next we need to take these and transform in negative direction by a value to not go over the rear zone. We can select all these nodes, press F, background. We can go in the main properties of the render, color management, and instead of filmic, we can set standard to maintain the correct pure white we set here. And in the modifier, we can set, for example, 1.1 to have a better result in the background below the pattern. Now, last thing, we can animate this result a little bit, adding a group node inside the rear and the front part. So I'm going to make this little group node, and I'm going to add the entire group node inside this zone. What we need is to move a little bit the vertices of our mesh before going in the mesh to curve node. And to do this, we can use the set position node and use this offset based by a noise texture. For example, you can use whatever texture you want, changing this to 4D to have this W to change the pattern in the 3D space of this noise. And we are going to link these in the scene node, linking the seconds and multiplying the seconds by a value to change the speed of the changing of this W, okay, so the pattern in the 3D dimension. Now, from this noise texture, we have this color information, that is the transformation in the 3D space. And because this color is an information that has a range number between 0 and 1, imagine that if you scale this range, you only have a range from 0 to a bigger number rather than the 1. So if we want to scale this effect in all the direction, we need to offset this range a little bit to go also in the negative zone. So from 0.5 and plus 0.5 in all the 3 axes of the 3D space. In this way, if we scale this range of values from the noise texture, we would have a correct expansion and diffusion in all the 3 axes of the 3D space. So to do this is very simple. We only need to take the color and subtract what? 0.5 for all the 3D axes. We are shifting the entire system of the noise pattern a little bit. Next, we can scale the entire effect using a scale and exposing these in the group input we are going to use for this group node. So now we can take all these nodes, press Ctrl G to make the group node. We can use a switch to enable or disable these. So I can use this in the group input to enable this effect. If I want to have this effect, I want to have the result of the set position. Otherwise, I want to link the original geometry in this case, so I'm going to rename this in the geometry. If the system is true, I want to take the original geometry, change the position and link these to the output. So now we can add another time the group input like this, and we can expose the speed of the animation. Speed. We can press H, we can expose the scale of the noise and also the scale of the effect, and we can rename it in scale effect. Press H to collapse, and we can link this to the offset of our mesh, and now we have this animation feature. We can get out from here and rename it in a correct name like image to graph animation, so we can add another panel inside our group input like this, calling it animation, moving these below the background, and also enabling the panel toggle to have the same check here. We can add the group input node inside our general group input, and before exposing these values, I want to change the definition of these input attributes. So inside, I want to set a minimum speed of 0, the scale with a minimum value of 0, and the scale effect with a minimum of 0. All these are simple structure like this. Now I can go out and expose these 3 values and link these enable to the animation. Now I need to take this speed and go inside the correct panel, like this. Press Ctrl H to collapse the unused socket. I can move this a little bit here and link this geometry here and this link here. Now I can take these 2 nodes and press Shift D to duplicate, Alt P to go outside the previous frame, press G and go inside this frame. I can move this a little bit down. And now it's important, I need to link not this original delete geometry output inside of this animation, but the result of this merge by distance before the mesh to curve. So I need to move this a little bit here, link the merge distance in the animation and link this in the mesh to curve. Now I can take these 2 frames and move a little bit here. And voila, we have the front, the rear, and the background. Now, if I enable the animation, you can see this strange behavior because we have a problem in the Z direction. And to fix this problem, we need to go inside, and here, before the scaling operation, we need to multiply the effect of this noise here by 1, 1 and 0 on the Z axis, because we only want the effect in the X and Y plane. I can go out, we can decrease the effect and press play, and this is the final result. We can decrease the speed like this, and this is the final animation of this 2D pattern. Anytime you can replace this image with another image if you want. We can rename this group node in image to graph, and to make this group as an asset, you can easily click with the right mouse button on this name and click Mark as Asset. Remember to save this file inside the path you have in the preferences for the asset browser of Blender. And if you need to transform any 3D mesh in this 2D pattern, it's easy because you only need to render your object with a camera, leaving a white background, and after making the render, you can instantly save that image and use that image inside this group node, and you have it. Another type of animation is this. You can also use the frames of a video, because here in the starting point of the graph, you can see this image texture, and you can see we have this frame, and from this node you can expose this attribute inside your modifier and control this frame with the frame of the timeline. So you can easily take this and link to the scene and frame. Now if I press play, you can see we only have one frame, but if you have multiple frames, you could use this technique. Finally, I take this group input, go to the select, grouped type, press Ctrl H1 and twice to have all the group input clean and the entire workflow ready to use. To use this asset, I remember you can go in the file menu, go in the new and general, and next go in the menu append and append the image to graph item from the subfolder node 3 of the blend file, or you can make it from scratch, or you can drag it on any mesh from the asset browser panel. Thank you guys for watching this video. I hope you like it, and I hope you learn something new. As always, you can find and download this file from my platform's links in the description. If you like my work, please subscribe to my channel, and see you to the next video tutorial. Bye!